Oh, I know that sound. It's time for the Beer and News Report. Hi, and welcome to the Beer and News Report. Cheers. Today I'm drinking California Blonde Ale. It's brewed by Eel River Brewing Company in Scotia, California. This is a good beer. It's got a nice flavor to it, a little malty, but it's organic, so you can't go wrong with that. I recommend you try it. Cheers. My best show to date is my interview of Dr. Aubrey de Grey. I follow him on Twitter, and recently he tweeted about a research project called Pearl that's testing an age longevity drug. So I contacted the team and I got an interview. This show is going to be that interview. But before we start, I want you to know that Pearl stands for Participatory Evaluation of Aging with Rapamycin for Longevity. So the drug they're testing is rapamycin, and there's two people in the interview, Dr. Sajad Zalzala and Anar Isman. This was done over Zoom, and Zoom can be glitchy at times. You will hear distortion, and at times the video sticks or jumps. That's just part of living with Zoom. So first, thanks Dr. Aubrey de Grey for giving me the heads up on this research, and now let's start the interview. Cheers. Hi everyone, welcome to the Beer and News Report. I have two great guests today to talk to. There's Dr. Sajid Zalzala and Anar Isman. Dr. Z, as he prefers to be called, is a physician licensed in all 50 states. He's an expert in telemedicine and is the co-founder of Ageless Rx. Anar Isman is the CEO and co-founder of Ageless Rx and has a Bachelor of Business Administration from the University of Michigan. Gentlemen, welcome to the Beer News Report. Cheers.
Thanks for having us. Yeah.
I should have brought a beer. This is a show on.
I'm non-alcoholic, so.
That's fine. That's fine.
This is an episode on longevity, so that's why we have to promote water and we drink water.
Yeah, I know. I'm going to probably shorten my life, but oh well. Dr. Z, I think we have something in common. I have a degree in electrical engineering. You also have a computer science degree, right?
Yeah. I started my career in computer science early on, but I gravitated more towards helping, technical support, troubleshooting. I want to work on people, not computers, and so that's why I kind of made the switch to medicine. But the technical skills from my days as a computer person has really paid off in terms of allowing me to expand my horizons with telemedicine and technology and things like that.
Okay, great. So you guys are doing this Pearl research project, and Pearl stands for Participatory Evaluation of Aging with Rapamycin for Longevity, and it's been tested on, well, first off, it's been used for patients that had transplants, like kidney or liver. And was there something that doctors saw in these patients that made them think, hey, there's something more to this drug?
Yeah, I mean, even as he mentioned this earlier, the scientists who work actually on rapamycin, on the mechanism of action, he, for example, immediately saw the antifungal properties, right? So rapamycin has very strong antifungal properties. And I think in that radio episode, we talked about how he used to carry with him, and like one of his friends had some fungus or something, and he would give it to her, fungus would go away. So even from that perspective, immediately they saw like antifungal benefits.
Yeah, I believe they then determined, like, I mean, they had this molecule. They saw it was a potent antifungal. The issue was, though, when they started giving it to lab animals, it would cause immune suppression, and that's kind of how it made ap way through the FDA pipeline as an organ transplant or organ transplant rejection drug. But I think when they started digging into exactly how it worked, they found this mechanism called mTOR that we talked about, and then we've got TORC1 and TORC2 and things like that, and that kind of led to this whole line of research on mTOR being a part of like a nutrient sensing mechanism for the body, and it turns on and off either if you activate mTOR, you kind of go into a growth mode, and you kind of build muscle, build cells, things like that. And then if you deactivate mTOR, it seems to turn on some of the housekeeping genes, and some of the frugality genes. Yeah, housekeeping genes, frugality genes, and that causes, anywhere there's misfolded proteins and things like that, the cell starts pulling them out of storage and things like that, and starts fixing them up and reusing them. And it's thought that's part of the reason why it can help make cells and therefore the organism live longer and healthier.
Excellent, excellent.
This is really interesting. This is by Arlen Richardson. You can look him up later, but he's a very prominent professor at University of Oklahoma. He's completely unrelated to us. This is just his presentation on rapamycin from a few years ago. But I think as we talk about rapamycin, we can scroll through it because it gives you really, really good summary of everything rapamycin anti-aging related. And you can then share with your viewers. But do you know the history of rapamycin? Shall we go into it a little bit?
I know it was used for patients that had transplants.
Yeah, I mean, it's interesting, right? They found it in the soil. That's why there's this statues here. It was found in the soil of Rapa Nui, the island, and they found it has certain properties like antifungal properties. And then it eventually got approved. Where is this thing? It eventually got approved by FDA in 1999, and it's being used as immunosuppressant, right? So for people who go through an organ transplant or a kidney transplant, for example, they get in larger doses, in chronic doses, to suppress the immune system so that your body doesn't reject the new organ. But then what they found, right, there's this mTOR complex. There's mTOR complex in your body. mTOR stands for mechanistic target of rapamycin. It's specifically impacted by rapamycin. And this is actually like a central, you think about it as a central coordinator of metabolism. It responds to certain clues, right? It responds to nutrient clues, for example, and certain hormones. And it kind of makes a decision. Shall growth continue or shall autophagy start, right? So what they found is, for example, cancer-prone mice, once given small doses of rapamycin, their tumors didn't grow as fast. So rapamycin controls growth. It also controls growth of tumors. And as you get older, you're not really growing as much. The only things that are growing by and large are tumors. You wouldn't hurt necessarily to slow down the growth of tumors.
Yeah, there's a very fascinating story done by NPR's RadioLab, where I think they spent like an hour talking about the history of rapamycin, how it almost got completely destroyed and completely lost to science if it wasn't for the scientists who smuggled it across the border in a ice cream tub. And then finally resurrected it. The other interesting thing about it is the person who actually smuggled it from Canada to the USA, he was diagnosed with metastatic cancer, colon cancer, and he was given like 6 months to live, but he was experimenting with rapamycin on himself. And it's thought that that extended his lifespan by 5 years. And it wasn't until he actually stopped rapamycin, voluntarily stopped rapamycin, because it's like, I'm not sure what's keeping me alive. If it's the rapamycin that's keeping me alive, I'll stop it. And then if cancer progresses, then we'll know what was the rapamycin all this time. And he stopped it, and unfortunately he ended up passing away. But it's a very, very interesting story. I encourage you to definitely listen to it. And it kind of gives a lot of richness to the history of rapamycin.
Oh, excellent.
I thought I knew everything there was to know about rapamycin until I listened to that radio episode. And maybe you can interview some of those folks too, but it's really, really fascinating. It's a Canadian scientist who worked on it, discovered it, and then the lab shut down, and he was supposed to throw it all away, and it would have been all lost. But against the rules, he kind of saved it in his own freezer. And then when they moved to US, he kind of smuggled it to US in a cooler. And then in the new lab, they were actually able to figure out how to get it FDA approved and stuff. So it's almost gotten lost.
Yeah, it was this close to being lost, the history, lost the science. Makes you wonder like how many of these molecules are out there and just never got developed for whatever reason.
Yeah, definitely. Is this similar like to penicillin?
In some ways it is. I mean, so penicillin is derived from a mold, very similar. I mean, although rapamycin is a bacteria derived, penicillin is derived from mold. These molecules actually are part of like microbiology warfare between bacteria and fungus. So in this case, the bacteria is making an antifungal rapamycin. It's a powerful antifungal. That's how it was first researched. And then in the case of penicillin, it was a fungus making an antibiotic to fight off invasion from or growth of bacteria. And a lot of our antibiotics are actually derived from fungus. And that's why there's this whole push of trying to find other molecules as part of this warfare, this warfare, so to speak. And it's possible you might find something even more, promising or different. And people are looking all over the place. There's an anti-diabetic drug that was from the Gila monster. Gila monster is this lizard that lives, I think, in New Zealand or something like that. The saliva of this Gila monster was taken, purified, and then turned into a drug, a diabetic drug. Yeah, very fascinating stuff. Although drug discovery is kind of moving more towards AI-based machine learning, so you don't have to you don't have to stumble upon it like they just happened to stumble upon this bacteria on Easter Island. They're trying to be a little bit more deliberate. So, but there's always something. I think we'll always get our best molecules from nature. That's where metformin is from. Metformin is a extract of French lilac that's been slightly modified for human tolerability.
Well, one thing I was going to tell you also, as we talk about rapamycin, I think one of your questions was kind of what are the studies that have shown rapamycin kind of benefits and health span and lifespan, right? The most important one is probably this one, conducted by National Institute on Aging. So ITP program, intervention testing program. Rich Miller out of University of Michigan runs it, but that's the one that showed, you can see the charts here, but that's the one that showed that even if given late in life, right, like 19 months is relatively late in life for mice, it still resulted in lifespan extension. 9% for males and 14% for females. And the reason why ITP program is so interesting is because it's done in 3 different locations, right? So they want to make sure that it's being able to replicate it in 3 different locations in a absolutely similar manner, in a very stringent kind of manner. And so it was replicated in multiple locations and multiple, multiple ages, like the mice given at old age, young age, middle age, but in many different occasions it was replicated to provide some kind of lifespan extension.
So you guys maybe not you guys, but it's been tested on yeast, worms, and mice. Is that normally how things are tested? Then they move to humans?
Typically, yeah. Typically, it started with lower organisms such as yeast or worms, such as C. elegans, for example, fruit flies, if there's a genetic component, and then usually works its way up to mice, and then sometimes it jumps right to humans if the mouse studies are promising. Sometimes it goes to an intermediate animal like a dog, for example, or various different monkeys or apes and things like that. But I think it all depends on the drug. I mean, I don't necessarily know there's a one-size-fit-all pathway for drug development. I think it depends on depends on the safety profile of the drug, the potential for the drug, the scope of the scope of the project, of the problem that it's trying to solve. I think there's a lot of variables.
Yeah, I think it's worth noting right here also, just really briefly, that Matt Kaeberlin out of University of Washington is doing the dog aging project, where it's a clinical trial of rapamycin on dogs, and they want to see if that ends up extending their lifespan and health span of dogs. So could be something really interesting for your audience, because everyone wants their dogs to live longer. Excellent.
And you guys, for this, the Pearl, you're in phase 4, right? So that's the last phase, right?
Yeah. Well, the clinical trial phases are a little bit difficult to navigate and a little bit confusing. Initially, we had applied for a phase 4, kind of after FDA approval, kind of like surveillance. But then we kind of had some discussions internally. We actually kind of changed that back to a phase 2 trial in terms of like kind of an early discovery trial. It's not a classic drug development pathway that we're taking, and so these phases, I mean, we're trying to almost like fit a square peg in a round hole, so to speak, where it doesn't quite fit with what we're doing, because we're trying to look at it from a repurposing mechanism for something that's not even considered to be a disease yet, which is aging and premature aging.
Right.
The phases matter more if you're trying to repurpose something and apply for a patent or like a new use kind of application, but we're not. Right? Yeah. It's not like this trial. We're not planning on generating some kind of new drug and raising the prices or these things. We're really purely doing this to advance the kind of understanding of the mechanism of action. And that's why, right, like we are focusing on kind of philanthropic donations, because it's not something that's going to result in a new drug that's patented. It's going to result in knowledge that could be used by any practitioners anywhere.
Yeah, you're expanding the uses of the drug.
Right. So I'm kind of developed for like new molecules, is like safeties, phase 2 is like small scales, phase 3 is like larger scale, and that you kind of need a phase 3 in order to get FDA approval, and then phase 4 is typically for aftermarket surveillance. Or like other potential uses. So like I said, like I said, trying to fit a round peg into a square hole or vice versa. It just doesn't quite fit with what we're doing. But we had to make a selection. So we have to select one of those for the clinical trials listing.
So in this trial, how many people do you have in it? Usually, how long? Can you guess how long it takes? And is it in one area or spread across the United States or the world?
We developed it as a virtual clinical trial. Traditionally a clinical trial, based on either a single center or multi-center, and the participants had to travel to that center to be seen by the investigator and things like that. When we first started out on this journey to do the Pearl trial, we wanted to make it as accessible to as many people as possible. So in that regards, it's open to almost anybody in the United States. Unfortunately, not outside the United States. That's a whole different logistical issue. But the trial itself will be a minimum of 6 months, but probably 12 months for kind of the first part of the trial. We've got over a dozen people already enrolled, and we've got dozens more kind of in various parts of the enrollment pipeline at this point.
So how does someone get in? I mean, I didn't know about this until it was tweeted by Dr. Aubrey de Grey tweeted about this, and I follow him, and that's how I learned about it. How would someone get into this trial? How do you sign up?
Sure. So we have a trial information page on our website. So if you go to agelessrx.com/pearl, you'll see kind of recordings of our webinar, an overview of the trial, and then there's a link to to kind of submit to be a participant. And so it's a very brief questionnaire, and it kind of gets the ball rolling in terms of moving through this participant pipeline that we have set up.
It is very, very simple, right? So this is the website, agelessrx.com/pearl, and then you'll have some webinars that you can view to learn more. There's also a link to see an overview of the study. There's links to some other studies here, and then you could click here and see if you qualify. And that would ask some questions, and then the research administrator would review it and see if you pass kind of certain quick exemptions. For example, you have to be older than a certain age, and then they would get back to you and schedule the next steps.
Excellent. Well, that seems easy enough. I'm just curious, what is the age limit?
50 and older. Yeah, we're recruiting people ages 50 and older.
Okay. And then if someone did sign up, what safety precautions are there? What kind of, what if you're allergic to rapamycin and you don't know it?
Well, the chances of that is pretty low, I believe. But if we have participants, check in with us on a regular basis, our research team. We send out questionnaires and things like that to kind of monitor for any kind of adverse reactions. Of course, if it's a more serious adverse reaction, there's a phone number, like a hotline number that participants are given, to contact us. And in terms of other safety, our goal with this trial is actually to help get a better understanding of the safety profile of rapamycin for healthy volunteers at the doses that are promising for longevity. And that really hasn't been done yet. You know, a lot of the trials on rapamycin are usually daily doses for, like I said, organ transplants, certain types of cancers and things like that. So we monitor that lab work. So most of the safety data is based on, you know, reported side effects, and then lab tests. You know, if we see something in a lab test, you know, we don't like, and we kind of troubleshoot and see what the potential problems are. And if it's something that's deemed to be a little bit more serious, we'll kind of have to pause the participation for that participant. But you know, overall, rapamycin is pretty well tolerated. We don't anticipate seeing any major major side effects or anything like that. So far, what we've been told, you know, by there are a couple physicians in the country who prescribe rapamycin for longevity. They're brave. I wouldn't, because I don't know enough about rapamycin. I wouldn't be comfortable. But there are a few physicians out there who do, and based on their feedback, I mean, so far, it seems like the most common side effect is cold sores. Sorry, not cold sores, canker sores. Which, you know, cold sores are on the outside, canker sores are on the inside, and that, you know, that usually goes away with time. But that's probably, you know, one of the more common side effects with rapamycin.
Yeah, I guess two quick things I would add, right? Dr. Z, correct me if I'm wrong. One is we'll be doing extensive safety measurements, right? Like when you join, you would be you do a blood panel and you do it again, 4 weeks later, and so we'll be able to monitor safety very carefully. And also, right, technically, we know that it's safe. It's FDA approved. It's already done through all the.
There's lots of safety data on rapamycin. I mean, and we're using doses far lower than, you know, than for example, a kidney transplant person. Now, of course, the caveat here is that, you know, kidney transplant patients tend to be very, very, you know, have a lot of other problems, very, very ill patients, and so the data on safety tends to come from those patients. And even then, it seems to be well tolerated, even in a population that's, you know, that's high risk for a lot of complications because of their, you know, their immune status. So that kind of reinforces the fact that we believe that this is going to be very safe. We just want more objective data, you know, from a population, like I said, an otherwise healthy population at the doses that we're hoping to target for longevity.
Hopefully, this will demonstrate the safety. And hopefully will also demonstrate efficacy, right? Because we're measuring a whole host of different metrics. But even if it doesn't, it still will provide really, really good information, right? Because we're collecting methylation age, we're collecting body density, body composition, we're going to be collecting a whole host of inflammation markers, and so sensory data. So this will provide a really good longitudinal set of data on large number of people that we hopefully will be able to get some really good insights from.
Okay. I'd like to switch a little over now to your company, Ageless Rx, and I've actually signed up to it. I'm going to try your metformin because it said one of the benefits is weight loss, and I definitely could use to lose 10 to 20 pounds. Tell me a little bit about the company and what the goals of the company are.
So the goal of the company is Ageless Rx is a telemedicine platform that puts people like you in touch with medical professionals knowledgeable about longevity, knowledgeable about how to slow down accumulation of age-related damage, right? Aging, right? It's common, what we call aging. What is aging? Aging is accumulation of age-related damage that ultimately leads to certain things, chronic conditions and breakdowns. So we put you in touch with very knowledgeable professionals like Dr. Z, who will be able to suggest what will be the best things for you to do. And that includes some Rx components like metformin, but it also includes certain recommendations on lifestyle, nutrition, and screening, right? Like it's very important. Big part of longevity is early screening and monitoring. Like if you have cancer, it's much easier to treat if you catch it earlier, right? So no point in doing certain Rx treatments if you don't catch cancer early, for example. So screening is very important.
Our ultimate goal is to kind of be like a one-stop shop, kind of the platform for longevity. You know, people who are interested in living longer and healthier lives. We hope to be able to provide products, services, recommendations, things like that to facilitate that. Right now, for example, we have metformin available. very promising drugs to kind of help stave off some diseases of aging like diabetes and heart disease, potentially even stave off certain cancers and things like that. There's some good trials on that, but it's just the beginning. Rapamycin is a much more promising molecule, but it's a lot more experimental, and that's kind of why we're doing this clinical trial, to understand it a little bit better, to ultimately be able to offer it on our telemedicine platform in the future. But like Anar said, I mean, we're kind of developing the platform to be a lot more of a holistic longevity journey for patients. Where we hope at some point in the future we'll be able to, like Anar said, offer blood work, potential screening tests, provide information and therapies on disease prevention for the top killers of like cancer, heart disease, dementia, things like that. And that's kind of where we're heading in the next few years with our organization.
One interesting product, right, that you might get recommended is CGM. Have you heard about it? CGM, continuous glucose monitor.
No, I saw a bunch of stuff on your website that I was like, I don't know what any of these things do.
CGM is a sensor the size of a quarter that you apply to the back of your arm, and it measures your glucose continuously. And so it's very easy for you to see it. It provides some really interesting insights. If you have a glass of beer, how much does it spike your sugar, and how long does your sugar stay elevated? How fast does it go down? If you eat a slice of pizza versus rice and beans and avocado. So you give you really interesting insights and how your body reacts to certain things, what happens to your blood sugar when you exercise or meditate or take a hot or cold shower. And also, of course, it'll tell you, half to a third of Americans are pre-diabetic and don't even know about it. So it'd be interesting for you to see what your fasting glucose levels are, when you wake up in the morning, for example.
Yeah. We just recently launched, we call it the longevity assessment, also known as the quiz, and it's a tool that it's still kind of, we just recently launched it, and we're working to improve it and add more features to it. But it gives a good starting point for people who may not necessarily know what they're looking for. It's a series of questions that we ask patients, and based on the responses, it helps guide some of their recommendations. And like I said, it's just kind of our first version of it, and as we kind of build on it, we hope to expand it and become a much more comprehensive platform for aging and longevity.
It seems like this is the future of medicine, telemedicine, because of COVID, I couldn't see my doctor. Basically, I did a blood test. I sent her the lab work, and then we did a Zoom call, and we went over everything, but I never actually went in to get checked out. Nothing happened. It was just reporting on what the results showed.
Yeah, we started well before the pandemic. We didn't even see the pandemic coming. It wasn't even on anybody's radar when we launched. But it's the silver lining, I guess, is that it really has catapulted telemedicine. Telemedicine went from something that was a little bit more of a curiosity, maybe had like 10% of market share. Now it's like, it almost forced the medical community to embrace telemedicine, as a viable option for patients. And a lot of organizations and medical organizations and things like that are coming around to the idea of, well, maybe you don't need to see your doctor inpatient for every single visit. And that's kind of what our philosophy is. Obviously, there's always going to be a need for inpatient care. There's always going to be need for people to see their doctor. Telemedicine does have its limits, although we are working to try to push those limits further and further. But it's never going to replace, proper in person, that touch. But we were hoping it'll supplement it, and provide tools that are not otherwise easily accessible to people.
Okay, and I saw a video, and you had talked about the difference between longevity and anti-aging, and I just want to make that clear to my viewers what the difference is, if you could explain that.
So I mean, it's more of I guess it's more of like vocabulary and terminology. So anti-aging has, and I guess a lot more association as well. So anti-aging has been associated more with things like, cosmetics, Botox, fillers, kind of looking younger or feeling younger. A lot of anti-aging doctors will employ, hormone replacement therapies and, stem cell therapies, things like that. And that's all well and good. I have no problem with that. However, that does, differentiate it a little bit from longevity, where the goal is to help people live longer and healthier. I mean, obviously, what's the point of live longer if if you're just going to be miserable, during that extra time that you spend. So there is a lot of overlap between anti-aging and longevity, but they don't fully overlap. There are slightly different philosophies, and that's why we stay on the terminology of longevity, even though that's not a perfect terminology either. But we feel it's a little bit
really
better
generally,
suited
right?
for what
Like
we're doing.
the high, if we can use a limited number of words, what you'd say instead of longevity, you'd say slow down in accumulation of age-related damage, and hopefully eventually even reversing, because age-related damage is what causes chronic conditions. Cancer, dementia, Alzheimer's, heart disease, are much more prevalent the older you are, right? Between the age 30 and 60, your risk of getting cancer goes up 1000x. So it's kind of one of those things where if we can actually slow down how fast that damage accumulates, that's goes much further in preventing or delaying those diseases than if you actually got a disease and then trying to treat it.
If you look at a graph of like, age versus kind of disease and functional decline, I mean, typically humans, the typical Western society human will start declining in their function and start accumulating diseases at the age of 50, for example. Some people are lucky and won't be till 60. Some people are unlucky and they'll start it when they're 30 or 40. So the idea of longevity and health span is pushing that curve out further. So instead of starting declining at the age of 50 or 60, you don't necessarily start, accumulating these diseases and accumulating these symptoms of aging until much later. And ideally, in an ideal world, you'd live healthy and vigorous until you're like 120, and then your last year of life, it all just kind of hits you, and then you leave this universe, you leave this world, in peace, knowing that you've lived a long, healthy, full life, with the least amount of disease burden as possible. That's what we think is potentially possible now. As more advanced technologies come online, we might be able to extend that amount from 120 to 130 to 140, and beyond. We just don't have those technologies yet, but I think they could be just right. It could be right around the corner. Could be another 10 to 20 years though. It's really, anybody's guess at this point.
I got my fingers crossed for rapamycin, but
yeah. Well, like I said, rapamycin has that promise to extend health span for sure, and we think maybe extend the lifespan. The challenges with humans is we're such a long-lived species to begin with. 120 years, 115, 120 years for our species. That's pretty long. I mean, there are not that many species out there that live, as long. And so to kind of any addition to that would be a really big deal. But for now, like I said, our hope is to kind of just, instead of developing diabetes at the age of 50, we're hoping maybe we can push that off for people until 60, 70, 80, or never.
Right. Well, I appreciate your time, and I hope that we get to talk again maybe in 6 months or so, just to see how the results went of the Pearl project.
Sure. It's probably going to be a little longer until we have results, but by then, hopefully, we'll be have completed enrollment and have maybe some preliminary data.
Yeah, happy to.
Excellent.
We do, yeah. Like I said, on that website, you saw we had a few recordings. We just had another webinar last night, and the recording will be up soon. We plan to have update webinars for our Pearl trial every couple months. And have new content every time. So stay tuned.
I definitely will. Gentlemen, thanks again, and cheers from the Beer News Report.
All right.
Thanks,
Cheers.
Wasn't that a great interview? I really like these guys. I hope their research helps us all. I put in the description a link to their website, and if you want to take part in the research, a link to their Pearl registration form. So, and if you want to contact me, I can be reached at this email address. And I hope you liked the interview. If you did, please click that like button. Of course, if you want to get notified of new shows, you click that subscribe button and the little bell icon next to it, and that'll let you know when I've posted a new show. Till then, keep your beer cold and your inches hot. Cheers.